Okay, so we are on the back of 1.1e table patterns talking about exponentials. So for exponentials, they're written in the standard form of y equals a times b to the x. And this works when you are generating consecutive, this will generate consecutive y values that have a common ratio, okay? The key thing with the common ratio is that notice that the difference between my x's is 1, right? We see that this 1, 1, 1, 1, 1, 1, 1, right? All right. The distance between your x's have to be the same in order for this rule to work. Like it can't be, oh, I went 0, 1, then I went to 3, and then I went to 4, then I went to 6. Like it has to be consecutive as well. Yes. We got this paper on Thursday. Yeah. If you didn't get it, it would be in folder 31 in the file cabinet. All right. So what we did at the end, we graphed this in the calculator. So in the calculator, I'm going to go to my handy dandy calculator, good old Sylvie, the calculadora. I'm going to reset her. 2 plus 7, 1, 2. So I reset Sylvie. I go to y equals, and I'm going to type in 7 times 3 to the x. So 7, that's not times 3 to the x. Okay. I need to look at the table. So I'm going to hit second graph to get to my table. Second graph. It opens up my table, and that's how I got the values for my table. Did we see that? Okay. So I got the values of my table. From there, 7, 21, 63, 189, and 567. All right. So when you look at, we're going to talk about the relationship here. So if you look right here, your A. So this is my A variable, my A comes from when x equals 0. So notice how it's 7 and 7. Then we did our common ratio. Your common ratio is your y2 divided by y1. 27 divided by 7 was 3. 63 divided by 21 was 3. 189 divided by 63 is 3. 567 divided by 189 is 3. Okay? Your common ratio, that's going to be your b values. I have no clue what I was trying to make there. Your common ratio is your b value. And notice, all that lines up. Yes. Orange 91. All right. So what I want you to do is take a moment, do the same thing with 8, and I will check or show you up here what you should have gotten. Okay. All right. So once you graph, you should have gotten your value. And once you input your equation, you should have went to the table and got your values. Now you're looking for what is the common ratio. And again, your common ratio means you're doing y2 divided by y1. So we have, I'm going to go to the table, away from the table, and I'm going to do 48 divided by 32. And I get 1.5. I do 72 divided by 48. And I get 1.5. 108 divided by 72. And I get 1.5. 243 divided by 108. And I get oh, I did something wrong. I did not get 1.5. I know. I put 4. I don't know what I put. Oh, I skipped a whole number. You saw nothing. You saw nothing. It's 162. Yeah, there we go. I was like, wait, that didn't feel right. 162. Yes. Okay. Yes. Are we raising our hand? Oh, yes. Are you raising your hand? Yes. All right. I'll be here in a second. So when you look here, we can double check ourselves that we did it right by checking that the values are where they are. So my A value should be my initial, my 0, 32. Is that matching up? Yeah. Yes. My ratio should be my B value. Is it true? Yes. So this is a rule that always happens as long as it's in the format of A a times b to the x, if y equals a times b to the x. Okay, so following this logic, can I fill in my blanks? Yes, I can identify my a and identify my b. What is my a? And why is that? It's the top, it's with your 0. So you know that this is going to be 625. So smart. Okay, how do you find your y? Divide. So I'm dividing 500 divided by 625, right? And if I do 500 divided by 625, there we go. That's my common ratio. So my common ratio is 0.8. So that's the equation that would fit this. Okay, and that's because I have a common difference and my 0 starts at a number other than 0. Okay. All right. Now, notice how I highlighted that it only happens when it's a times b to the x. If there's anything being added or subtracted, then that's not going to work. Those don't uphold. Okay. So I'm going to do 10, but we're really not going to, we don't have time, or I need to worry about 11. Yeah. So I want you to fill in the table for 10, and then we're going to look at the pattern. Okay. All right, here we go. What values did we get? 10. What? 14. 22. What? 38. And what? 70. Okay. Now we're going to find our common ratio. Remember, ratio is your y2 divided by your y1. So 10 divided by 8 gives me a number. Yep. So 10 divided by 8 gives me 1.25. Then I'm going to do my next set of y's. 14 divided by 10. And I get 1 4/10. Oh no. I'm going to do 22 divided by 14. And I get 1 57. We'll do 38 divided by 22. And 70 divided by 38. Notice how these are not the same values, are they? No. Not at all, like nowhere near. So what this tells me is like, oh no, it can't be exponential. Well, it is exponential. It's just not an exponential in standard form, okay? It's not an exponential in your a times b to the x. It's an exponential in a different format. So what does that mean? Well, when this happens, when we are not in standard form, this right here, we are in adding or subtracting a d value, you have 2 steps to take. You have to find the difference and then the ratio, okay? So in this situation, our difference is going to be y2 minus y1, and our ratio is going to be difference 2 divided by difference 1, okay? And that's how those values are going to come into play. So this is going to work always for any exponential, but the first way only works if the exponential is in the original format, okay? So I'm going to graph and fill in my table. I need this to move so I can come over here. No, I need you to go to the other side. Go to the other side and stay. Just don't move. Oh my gosh. Sylvie is not having it right now. All right, so we're going to go to y equals, and we have 1 5/10 times 3 to the x power. Forgot my x didn't make. Plus 22.5. I'm going to go to my table by pressing second graph, and there are my values. I have 24, 27, 36, 63, 144, and 387. Okay, now I'm going to find their difference. So you would do this if you didn't have the equation. Let's say I didn't have this equation, but I had this table, and I would need to try to make the equation. Does that make sense? What would I do? This is what we're going to do. All right, so we're first going to find our difference. So to find the difference, 27 minus 24 is 3. 36 minus 27 is? 63 minus 36 is? 144 minus 63 is? 387 minus 144? 243. Okay, that's your difference. Now you're dividing your differences. 9 divided by 3 is? 27 divided by 9 is? 81 divided by 27 is? And 243 divided by 81 is 3. Okay, so now we can draw some conclusions here. So our B value is still our ratio, but only after we found our difference. Does that make sense? So there's our B value. Okay, our A value is where it gets tricky. So our A value is now a combination of two things. Your A value, it comes from, well, your 0 now comes from your A plus your D. Do we see that? 1.5 plus 22.5. Yeah, you see it? And that's how you get your 0. Because if I had $1.50 and I have $22.50, together it's going to make $24. Okay. All right, so your turn. Yes. Okay. You're going to do 13. And then in your own words, you're going to summarize what we said the connection is between each letter from the table. Okay. All right. 13, and that's it. You remember too late?
I got two different.
Oh, y'all are killing my soul. All right, here we go. My Y values, what are they? 82, what? 66, 58, 54, 52, 51. Okay, now we're subtracting 66 minus 82 because we're doing Y2 minus, and we get what? 16, negative 16. You know how I already put your negative there for you? Okay, 58 minus 66, negative 8. 54 minus 58, 52 minus 54, 51 minus 52, negative 1. 8 divided by 16. 0.5, a half, right? 8 divided by 16 is 1/2, correct? 4 divided by 8 is? 2 divided by 4 is? And 1 divided by 2 is? A half. I know I did this right because what? Exactly. My 0.5 is my B, my ratio, yes. And my 0.82 is 32 plus 50. Yes? Okay. Do we see the table patterns, the relationship between that? All right. So at the bottom, I'm going to leave for you to do. I'll check when I do notebook check, but in your own words, you're explaining what patterns that we find with these tables. So what was the relationship between what? Yep. All right.